In this nugget on IP addressing, we're going to tackle 6 main knowledge areas. First of all, we're going to look at the overall structure and the binary structure to the decimal structure of the IP version 4 address that's widely in use now. Then we'll talk about the different address classes that were created to preserve IP address space. Then we'll talk about private reserved addresses, why they exist and how they're used. We'll look at the concept of IP subnetting. Then the 3 main ways to assign IP addresses, and then finally we'll finish off looking at IP version 6 or IP next generation. One of my favorite questions to ask in a classroom training situation, which is really kind of a trick question, is how many numbers in an IP address, the IP address that's used, the logical address that moves packets across the internet. And I'll hear different various answers. I'll hear 4, I'll hear 32, I'll hear 16, various numbers. But the truth is, it's really just one number. It's one string of 32 zeros and ones. Remember my motto, it's all zeros and ones, baby. So really an IP address is really a field in the IP header that's appended to the data that's moved between the routers in an internetwork. So here's an IP version header, which is really a bunch of fields that just simply have zeros and ones in them to basically have control information for moving these packets from router to router to router across an internetwork. And you can see down here that you've got 2 fields. These are fields that will actually fit 32 bits. The source address and the destination address, which just happens to be this string of 32 zeros and ones. If I just take those bits and kind of pop them in here, you can see those 32 bits go right there in the source address, and I could pop 32 more down here. That's how it looks to the computer, this string of zeros and ones. Well, what we want to do is, we don't really do well with zeros and ones. As human beings, we would really like to work with, digits. Because why? Because, well, we've got 10 fingers, and we use a base 10 numbering system that really kind of fits our physiology and really our mindset. So we want to find a way to convert this string of 32 zeros and ones into some kind of readable format that we can use on applications and configuring our network devices so that packets can be sent to logical addresses across internetworks. Well, let's do that. Now, the first step in creating a readable IP address is to separate these 32 bits, this string of zeros and ones, into what we call octets. So we use a dotted decimal here, this little red dot, to create 1, 2, 3, 4 octets. Now, an octet is basically just a group of 8. I mean, think of like Earth, Wind, and Fire from the 70s, or, some rapper with his posse. 8 people up on stage on Saturday Night Live. So we've got a group of 8 here. Now, to be able to understand how we get this IP address in these 4 octets to a readable decimal format, it really helps to understand the values of the placement of these bits in an octet. So let's talk about that next. I've said this to many of my students in the past, and I'll say it again to you. If you absolutely hate math, you may be in the wrong business because you just can't avoid it. Again, it kind of goes back to the fact that I love that show Numbers because I do really like math. I'm not a math genius or a math whiz, but I do like numbers. And you need to understand here that this octet is really 8 bits. And each one of these bits has a value. The bit on the far right, again, let's just go ahead and imagine that we're taking this first group here, this first octet, and shifting it down here. We've got 1, 2, 3, 4, 5, 6, 7, 8 bits. This is called the low order bit on the far right. Over here on the far left is called the high order bit. Each one of these bits has a value if you turn it on. So if you turn on this first low order bit, the value of that bit is 1. If you go to the second bit, if it's 0, well, the value is 0. If you turn it on, it has a value of 2. The third bit, a value of 4. And you can see how this exponentially doubles as we go. Now, if you take this octet and you add up all of these numbers, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you get 255. Okay? If you don't trust me, grab your calculator and add it up. It adds up to 255. So if you turn all the bits on in an octet, the highest number you're going to have is 255. And we'll see later that that's actually kind of significant. Now, realize that your possible values, the possible number of values is actually 256. Why? Well, don't forget, if these are all turned to 0, okay, remember 0 is a number, so that's a possibility. So between 0 and 255 are your possibilities. That gives you 256. Exponentially speaking, that happens to be 2 to the 8th power. 2 to the 1, 2, 3, 4, 5, 6, 7, 8th power. All right? Are you starting to see the math here? This is really basic high school math. But, and again, let me repeat, if this makes you nauseous, just sitting here listening to this, then you might want to reconsider. No, I'm just kidding. You can actually get past the math very easily and have a great career. I'm just trying to give you a hard time. But now, we see that we have a value, we have an octet here. And again, each one of these octets has a maximum value of 255. If you turn all the bits on, you get 255. That's very important. Now, let's take it one step further as we move towards a viable IP address. If we look at the actual first octet, the low order bit is turned off because it has a value of 0. The second bit, or the 2 bits, turned off. The 4 bits turned off. 8, 16, 32, these bits are all turned off. But the 64 bit is turned on and the 128 bit is turned on. So the value of this octet is 128 plus 64 plus 0 plus 0 plus 0 plus, you get the point here. Basically 128 plus 64 equals 192. That's the decimal value of this first octet. The second group of 8 of that original 32 bits, or our second octet, has a value of turning on the 128 bit, turning off the 64 bit, turning on the 32 bit, turning off the 16 bit, turning on the 8 bit, and turning the remaining 3 bits off. If you add 128 plus 32 plus 8, you get 168. So the value of the second octet is 168. You seeing it? I know you are. Good job. Okay, for this third one, you're on your own. I'm going to let you figure this one out for yourself. Now you can go ahead and pause the video. Maybe you can back up a little bit and go look at the screen that have the original values on this, and then add up these bits and tell me what the value of this third octet is. 101. Brilliant. Excellent job. Again, 64 plus 32 is 96. Plus 4 is 100. Plus 1 is 101. Go ahead, pause the video and figure it out. You guessed it, 45. Okay? 32 plus 8 plus 4 plus 1 is 45. Now we have 4 octets. 192 is the first octet, 168 is the second, 101 is the third, and 45 is the fourth. So now we can see our original string of 32 bits here gets separated by 3 decimal points, or 3 dots, to create 1, 2, 3, 4 octets of binary numbers that get converted to decimal numbers. 192.168.101.45. Now that's an IP address that I can understand, and my applications can understand it as well. But again, this is an address, right? So just like sending, let's say, a letter through the U.S. Postal Service, I'm going to put some information on the outside of that envelope. Well, that information is going to basically, let's say I'm going to send a Mother's Day card to my mom. On the outside of the envelope, forget the logical name. Forget her name for a second and just realize her address is really going to be kind of a combination of 2 different things. The locality, her location, and then her house number or her apartment number within that location or region. The same thing here with networking. This particular